All right, here we go. It's day 9. Um, in short, we have, where am I? There I am. In short, we've got, oh, I've got to sneeze, terrible. And I haven't sneezed on recording before, I don't think. All right, it's passing. Anyway, we got these sequences. We've got a list of sequences, and our job is to predict the next number. Um, I I was reflecting on yesterday's as well as a few other challenges, and this year I suspected that we would have a bit of machine learning in the mix just because of how topical it is. And I think we're starting to see that. There was, which one was it? There was yesterday, of course, which I've seen some people solving it with like wave harmonization, which I thought was pretty, well, I mean, it's essentially the same solution, but it's a pretty neat way of looking at it. And in a sense, you're fitting a function to data, right? And you need to pay attention to the properties of those data in order to do it well. More on that to come. And then there was also, what was it, 5 with the no, no, it was 6. Yeah. Yeah, this one, which was about finding the intersection of, you can visualize it as I did as a graph, and then you as a curve, and then you find the intersection with a line. Um, Seems kind of machine learning to me. Maybe not. This one, definitely machine learning, right? I was actually wondering, I don't know anything about regression, but if I needed to come up with regression from scratch, this is probably what I would do. Um, Again, I may be talking complete nonsense there, but it does seem a little machine learning, right? So maybe we're starting to see that come through. Um, I was also reflecting on yesterday and how, essentially if you looked at the data at the input and you learned some things about it, then you could solve the problem. You knew it was easy to see how you would solve the problem, or at least much easier to see that a lot of the edge cases were not there. Um, and so I think what I took from it was, if the problem seems intractable, maybe some features of the data will help. And then how do we differentiate intractable versus large? So I get a feeling this is going to be, it's going to take a lot of computation, but I don't have a strong intuition for when something will take a very long amount of time versus just a bit of time, and how much more efficient the shortcuts that I found will make it. Um, Now, in principle, big O complexity, right, should solve that problem for me if I can work out a way to apply it. So I guess maybe that would be a good exercise. In this case, it seems like, well, we have a reasonably modest number of inputs, both in width and height, and the calculation appears to be it narrows in towards a essentially 0. So it will be hard for this one to get out of control, at least in step 1. I may live to regret that, but I can't see any way that it would really get out of control. So the challenge then is, we have a nice visual explanation here. How do we code this up? Really, it's just a matter of working out how to express it in code, as far as I can tell. So let's try it. The first thing I'm going to do is the technique that I use when teaching quite a lot, or at least that I teach people to do, which is, let's pay attention to how we do it as people as we go through it. So in this case, we make another list. We start populating, and we see, okay, 3, 3, 3, 3, 3 is the distance. Are all of these the same? Yes. So here, like here we can say, no, they're not all the same. Here we can say, yes, they are all the same. So we've reached a kind of point where what I'm wondering is, just to elucidate my thoughts, is in the example they also go as far as this, and this is how they tell whether they're done or not. Uh, so they are the same, but also they're all zeros. This is what it asks to look for, um, which is really the same thing as them all being the same. It's just whether you decide to match on all zeros or whether you decide to match on all the same. Maybe it doesn't, it probably reduces to the same thing anyway. In any case, now I know that I've got it right. I've analyzed the problem. I've analyzed the sequence properly, and my job now is to calculate the next one. So at this point, I just add another 3 on the end, and then I add 3 to this, and I get my next number, which is 18. So that algorithm works, right? If we were going to code it up, then yes, then our algorithm could be this is where it gets like slightly tricky, which is how you can code it up visually, but how are you going to code it up in actual code? And I sense there's a recursive solution here. I sense because well, I know there's a recursive solution here. So we could say that we could define it like this. Are we overcomplicating this? Why am I finding this hard to think through? Probably because I'm thinking recursively. Let's try and define an increment. Is this right? So let's take this example again. We want to find I. The differences here. So we've calculated the differences. Yeah. Okay, so I then we can do this. I'm missing some sort of something something here. Let's try and solve it a different way. Solve it using iteration. Maybe that'll make it clearer in my head. This is right, isn't it? Just I've just written a recursive solution. Um, okay. So there's a way of simplifying this, right? Yeah, that would work, right? So okay, let's try that. Okay. If the sequence is all zero, return zero. That's not true. Let's call this S, and let's call this D1. Let's make these smaller actually. Okay, D1. This needs to be one less. Yeah. Um, okay. D1. For item in sequence, calculate the difference between this and next item. Of course, we'll ignore the final one. Okay, so this is 3, 3, 3, 3, 3. Return last item in, so return, and okay, now, so what we do is we return the last item in sequence plus the result of calling this again. Zero, 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 zero. R2 should be 0 plus. And then when we get down to the next one, R3, because they're all zeros, is going to be 0, 0 plus 0, 3 plus 0, 15, plus 3, 18. Yeah. Okay. That works. All right, let's plan some stuff out. Okay, starting to see what step two might be. What's the final result? Okay, need a parse line and calculate. And so our plan is going to be by the way, we do have some minus numbers in this, so just worth bearing in mind that. Okay, I think we should be pretty good to go on this. I can only imagine what step two is going to be like, but I guess we'll probably generate loads of them, loads of results. Uh, yeah, okay. Switching to the code. Got my trial and my input. Reset the timer and get started. No. I don't need to start memorizing yet. I'll do that later. Okay. Just seeing people skip the first one as a way of making this logic slightly easier. So, okay. Great. Just want to have this return a sequence to make the next function slightly easier. Okay. Sequences of length empty. Sequences of length null. Do we care? Uh, hmm. Okay, that works. Or appears to. Do I even need this? Yes. Okay, that's 114. Correct. Now let's try it with the input. It's a little while. Anyway, let's try it. 946. Okay, not bad. Let's look at part two. Yeah, even more history. Extrapolate backwards as well. For each history, repeat the process of finding differences until the sequence of differences is entirely zero. Then, rather than adding a zero to the end and filling in the next values of each previous sequence, you should instead add a zero to the beginning of the sequence of zeros, then fill in the new first values for each previous sequence. In particular, here is what the third example history looks like when extrapolating back in time. Adding the new values on the left-hand side of the sequence from bottom to top eventually reveals a new leftmost history value 5. Doing this for remaining example data above results in previous values of -3. Well, this doesn't seem so difficult. I mean, in theory, we just take the first number and subtract it from the first one, right? Let's just quickly try that because I mean, I know it's probably an easy day puzzle, but I would just like to check. Sorry, 3 minus 0. And this gets us -3, right? Yeah, okay. Well, seems okay. All right, I'm not going to overthink it. Let's get started. Wait, plan. Plan. Don't get lost in it. Okay. Plan. Yeah, that'll be fine. Lucky I planned there. I was about to really lose my head. Okay. All right, let's get this started. Reset the timer, and let's go. Oh, this will be 0. Yeah. But does it even matter if we do it that way? Well, we probably should. Yeah. I mean, I haven't actually checked it with a fuller stack, but well, let's assume. 2. Yeah, okay, and 905 is the correct. Well, we hope it's the correct. Let's find out. Okay, well, it's got to be my fastest one in a while. All right. As despite my attempts to overthink things, it was, I think, a pretty straightforward day, unless I've missed something, missed a real trap. Yeah, nothing much to learn from this, I think. Cool. See you tomorrow.